In this section here, we're going to be talking about complex numbers. And I'm here to tell you, if you've never seen this before, this is definitely going to be a different concept. And the previous sections we've worked with, we were in the real number system, and denoted as R here. The complex number systems is an extension of the real numbers. And here's a reason why we had to extend the real numbers. Take, for example, this equation right here. Well, there isn't a number that we can plug in for x that gives us out -1. In other words, two numbers multiplied together, well, I guess they're the same number multiplied together, that gives us -1. There are no numbers that come from the real number system that can do that. And so we extended the real number system and we added the complex numbers to it. And what I can plug in now into x is this thing called I. Alright, it's the letter I, and if we square I, we get -1. Yeah. If I square root both sides, I is equal to the square root of -1. So now if we get negatives under the radical, we'll know how to handle them. Okay, we'll know how to handle this. So here's an example. The square root of -81. Well, there isn't a real number that we can square root. Okay, a negative real number that we can square root. But I can break this up. This can be considered to be -1 times 81. And of course, we can break this up as the square root of 1 times the square root, that's square root of -1, times square root of 81. Okay, properties of the radicals there. Can break that up. Now, what did I say the square root of -1 was? It's I. And the square root of 81 is 9. However, we would normally write it like this, 9i. That's more the standard form there. Okay, so the square root of -81 is 9i. I know it sounds strange, but that's what it is. Okay, let's look at another one. If I had, for example, negative square root of -121, this is negative square root. Now I'm going to break this up as -1 times times 121. Okay, I'm not going to always break this up. I'm just doing this here in the beginning. But so we know what this is. This is I, and the square root of 121 is 11. But we want to write it in this standard form, -11i. Okay. All right. Let's look at another one here. How about if I had not done that? Okay. Negative square root of -20. So this is negative square root of -1 times the square root of 20. Now we can break this up. Now, okay, square root of -1 is I. Let's just get that out of the way. We can break this up as 4 times 5. And of course the square root of 4 is 2, and we can't break that down anymore. And the standard form would be -2i, and we'd write the radical over on the right hand side of the I right there. Okay, on the right hand side. Alright. Let's see, 3 square root of -48. So this is going to end up being 3 square roots of -1 times the square root of 48. I'll just write it down here, bring it down, 3i, and 48 can be written as the square root of 2 to the 4th times 3. Okay, which is 3i, and the square root of 2 to the 4th is 12. So we have the square root. You know, um, it's amazing how I went from 48 to this right here. It was a big jump, wasn't it? If I have 2 to the 4th, and it's all raised to the half power, okay, because that's what this radical is. And of course, you know, you got 3. If I'd actually break this up, half times 4 is 2. So that becomes 2 squared there, which is 4. So we write a 4 here, and then I'm just going to go ahead and write it back in radical form, this here. Okay. So we end up with 12I and the square root of 3. Okay. Of course, that's got to happen at least once. What about if I had the square root of negative 81 over the square root of negative 4? Now I'm not going to break this up like I did in the past. We know if there's a negative under here, there's going to be an I involved. So the square root of 81 is 9. And then of course I can just write an I there, and the square root of 4 is 2. I, but I over I, those cancel out, and we're left with 9 halves. So this reduces down to 9 halves. Okay. What if I had the square root of negative 4 times the square root of negative 9, and it's all over the square root of negative 16? Well, we just do these one at a time. The square root of negative 4 is going to be 2I, and the square root of 9 is 3. Of course, that negative under there, we're going to add an I there. And square root of 16 is 4, and of course I. Well, we can cancel out, right, one of these i's, one on the top and one on the bottom, and so we're going to be left with 6I over 4. But of course we can reduce this down. 2 goes into 6 3 times, and 2 goes into 4 twice. So 3 halves I. Okay. What about if we had negative square root of negative 25 over the square root of negative 1? So this becomes a negative 5I over I. Of course, the i's cancel out, and you're just left with negative 5. Easy enough. Alright. Now what we're going to talk about is the a plus bi form, the complex number. This part here is the real part, and this part here is the complex part. Okay, or I'm sorry, the imaginary part. Real, imaginary. All right, I is really imaginary, short for imaginary. The imaginary number. 2 plus 3i. If we were to add that with 5 minus 6i, we're going to add the real part, so 2 plus 5 is 7, and 3i minus 6i is negative 3i. But of course, we're going to write it as 7 minus 3i. We wouldn't write a plus and a minus there. 7 minus 3i. All right. Let's look at another one real quick, if I can get it in. Negative 4 plus 7i plus 3 plus 2i. So that's going to be a negative 1 plus 7, 8, 9, 9i. All right. That's the form we want. Let's say that I've got negative 11 times 2 minus I. Well, we distribute the negative 11 across. We have negative 22 plus 11I. So that's pretty simple. Always trying to work something simple and then progressively get harder. Alright. We're going to multiply two complex numbers, 6 plus I times 3 minus 4I. So 6 times 3 is 18. 6 times 4, negative 24I. And then I times 3 is 3I. Then I times I would be I squared. Now we end up with 18. We got negative 24 plus 3 is negative 21. I minus 4. Now remember that I squared is equal to negative 1. So we have 18 minus 21I plus 4. And of course we can simplify this down. 18 plus 4 is 22 minus 21I. And that of course is the form that we want to get it in, the A plus BI, remember, form. Alright, of course we gotta work a couple more of those like that. 6 plus, we already did 6 plus. Okay, yeah, we already did that. Let's do negative 8 plus I times 9 minus 3I. So negative 8 times 9 is negative 72. Negative 8 times negative 3I is going to be positive 24I. And then that's plus 9I. And that's going to be negative 3I squared. And of course we can rewrite this as negative 72 plus 24 and 9 is 33. I minus 3 times negative 1. So we replace the I squared with the negative 1. So we have negative 72 plus 33I plus, because we have a minus and a negative, makes that a positive. Negative 72 plus 3 is negative 69 plus 33I. And that's the form that we wanted in, right there. Okay, let's look at another one here. The square root of 3 plus I times the square root of 3 minus I. So the square root of 3 times square root of 3 is just 3. Square root of 3 times I is negative I square roots of 3. We always put the radical on the right hand side of I. And then that's going to be minus I squared. And of course, those are going to cancel out. We have 3 minus negative 1 squared, and that becomes 3. Negative 1 squared is 1, so that'd be 3 minus, or where am I at here? I squared is equal to negative 1, not negative 1 squared. Okay, 3 minus a minus 1 is 4. Boy, I about made a mistake there. Yeah. Okay. What's going on next? What is on the agenda next? Let's see. We got 5 over 3I. Now we want to get this in the form, remember, A plus BI. This is the form that we want to get it in right here. So we got to get rid of this I in the bottom, and the way we're going to do that is I'm going to multiply the bottom by I and the top by I. That's pretty easy, because now we're going to have 3 times I squared. And remember what I squared is equal to. It's equal to -1. So we have 5I over 3 times -1, but we can take this negative and just bring it out front. And this becomes -5/3 I. So there's not a real part here, but that's okay. We've got the imaginary part. Just something you gotta imagine, I guess. Anyway, let's see, what do we got going on next? How about 4 plus I over 2I? This can be broken up, but instead we're going to do it like this. We're going to multiply the bottom by I and the top by I, just like we did in the last problem. So you distribute this I across, and you get 4I plus I squared over 2 times I squared. And we'll just continue that right down here. And so we end up with 4I plus -1, right? That's replacing that I squared up there. And then 2 times -1. And of course, I can go ahead and break this up now. This is going to be 4I over -2. And then we're going to have a -1 over -2. But we can rewrite this. This is -1 over -2, so the negatives cancel out. And of course, I'm going to write it in that A plus BI form. And then this becomes -2I. That's this piece right here. 2 goes into 4 2 times. All right. Okay. What about -4I over -3 minus 5I? So what I'm going to do here is I'm going to multiply. We'll rewrite it again down here. I'm going to multiply the bottom by, this is known as the conjugate. This is the conjugate of this guy here. So -3 plus 5I. We've done this in the past. I just never called it that. Alright, so -4 times -3. Actually, I think what I'm going to do here is just write it down here. -4 times -3 is positive 12I. -4I times plus 5I is going to be minus 20I squared. Alright, over, so -3 times -3 is 9. -3 times 5 is -15I. And then -5I times -3 is positive 15I. And -5I times positive 5I is -25I squared. Now we can rewrite the numerator as 12I. Now remember, that's a -1, so that's a negative, so that makes that a positive. Over, okay, those terms cancel out. We end up with a 9. Okay, this I squared is replaced by -1. We got to remember. And of course we have this -25 here, and the -25 times -1 is a positive 25. So we don't want to make that mistake. And so now we have 12i plus 20 over, and 9 plus 25 is 34. Now we want to write this, remember, in the a plus bi form. And so we're going to take the 20 over 34 plus the 12i over 34. But we want to reduce down this fraction right here, and let's see, 2 goes into 20 10 times, 2 goes into 34 17 times, and plus, and then the same thing here, 2 goes into both of those, and so there you are. 10 over 17 plus 6 over 17i in the a plus bi form. And I do believe that I think I'll end it with that. Okay. Alright, we're going to simplify, do some simplifications here. What if we had I to the 30th? Well, what I'm going to do here is I'm going to write that as I raised to the second, all of that raised to the 15th. So 2 times 3, or 2 times 15 is 30. But remember what I squared is, it's -1. So -1 to the 15th, because this is an odd number, a negative raised to the odd number is going to be positive, right? So that just ends up becoming -1. Okay. If I had I to the 91st, we would want to rewrite that as I times I to the 90th. And that can be rewritten as I times I raised to the second power, and all of that raised to the 45th power. So we have I times, and I raised to the second power is -1, remember? And of course that's an odd number. And so that becomes a -1. All of this right here, so we end up with -I. I want to bring that negative over to the left. Say I had a -I to the 27th. So we're going to break that up into -I squared times I to the 25th. No, actually, we don't want to do it that way. I just seen something. We want to break it up like this. There we go, to the 26th. So now we can write this as I squared, and all of that is raised to the 13th power. So we have -I. Remember, I squared is -1. It's raised to the 13th power. So we end up with -1 raised to the 13th power is going to be -1. And a negative times a negative is positive, so we end up with just I there. Okay, this is -I raised to the -29. I'm going to rewrite this. This is -1 over I to the 29th. And of course, this part here, we're just going to focus on that. That can be written as I times I to the 28th. I times I squared, and all of this is going to be raised to the 14th. Right, breaking up this 28, 2 times 14. So now we have, and -1 raised to the 14th is a positive 1, so we're just left with an I here, so that's just going to be -1 over I. And of course, we multiply the top and the bottom by I, so we have -I over I squared and negative I over negative 1. So this all reduces down to just I. Right? Negative over negative is positive. So this is equal to I. If I had negative 7, I to the 0, well, I to the 0 is just 1, so you're just left with negative 7. Here's a good one here, 3I to the 25. So this becomes 3I times I times, so I scratched that out. I broke this up, I times I to the 2524, right? We subtracted 1 there, add their exponents. Rewrite this as I squared raised to the 1262, because those two multiplied together gives us 24, I'm sorry. And I squared is negative 1, and the negative raised to a positive power is going to be a positive 1, and so we're just left with 3I. So this guy is equal to 3I.